Okay, so I'd like to just briefly talk about some forces that are important with Newton's first law. These are forces whose job really is just to balance other forces. These are called reaction forces. So reaction forces balance other forces. They don't really have any other job. They don't really have a formula. Well, they can have a formula. We'll use a formula, but that formula usually has to do with the breakdown of the force, right? So we'll look at a few of these. The first one would be tension. It's really a force from the tension in a rope. So if I have like a rope and a box, there'll be a tension pulling up on the box. There's a tension actually in the rope, T, and that is going to pull up on the box and pull down on the ceiling equivalently. But that's not the important thing, is that at the end of a rope, pulling into the rope, there's a force pulling into and along the rope. So if you have a rope here, and you know you've got somebody pulling it over here, another guy pulling it over here, right? This guy's pulling this way, P. That means that the rope is going to pull back P. Right? If he's pulling the rope here, P, he's also pulling this guy, P. This guy has to pull back the same amount to stay stationary, which means over here this guy sees the same rope, P. The rope is always pulling whoever's touching it into the rope, right? It can't pull away from the rope, right? You can't pull away from yourself. You have to pull into yourself. The rope's never going to push anything. You can try this, take a piece of string and try to push a coin across a table if you'd like. And that's more or less all there is to ropes. If the rope is at an angle, like that, then when you pull, that pull is at an angle, right? This box is going to get pulled along that rope at an angle. That's about it. Then we have something that's called the normal force. This is a force perpendicular to a surface. It's normal to a surface. So the normal force is perpendicular to a surface, the force perpendicular to a surface. That keeps objects from passing through it. Okay, so you have a table, and you put a box on the table, and the table pushes up on the box, just as the box is pushing down on the table, same amount. So whatever the weight is on the box, for example, the normal force is. The reason why it's different from the weight we don't have is that you could have this on an incline or something like that, and the weight is coming down here. In fact, you can have a normal force that's perpendicular. So let's say I put a book here, and I push this way with my hand. The normal force on the book will be perpendicular to the wall here. So the normal force is always perpendicular to the surface. It's not equal to the weight. It's not always vertical. And finally, we have static friction. This is the opposite, or the perpendicular thing. This is also on a surface, but this is the thing that keeps things from sliding. So static friction keeps objects from sliding. Along a surface. And here we have actually a symbol here. We're saying that this force of static friction is always going to be less than or equal to this constant, the coefficient of static friction, times the normal force. So the heavier something is, the greater the friction that it can withstand. This is because, you know, objects are rough, and so because they're rough, it's hard to slide against them. That's the main idea. And so this is the limit. Now there is a limit to a rope. What happens is the rope breaks. There's a limit to a table. The limit is the table breaks, right? For static friction, you don't get anything that interesting happening, right? Maybe you could get a little bit of wear, right? If you want to get an idea about what's happening with static friction, you know, you can, or what's happening with friction, you know, get some sandpaper, right? Sandpaper is high friction, and it's actually wearing off the things that you're wearing with. That's actually kinetic friction, but still, it's sort of a similar mechanism. So that gives you your static friction there. So those are the three reaction forces. The important thing is that they usually balance out other forces. The tension is, and the other thing is the directions. The tension is always along the direction of the rope or the cord or the string or whatever it is. The normal force is always perpendicular to a surface, and the frictional force is always parallel to a surface. Once you've got that down, you've got everything you really need to know about these things. You just have to be able to apply them with Newton's first law. So as long as you can do the vector addition, then you know everything you need to know about these guys. They balance out other forces. If you're not given them, you have to look to Newton's first law to tell you. Like we'll show you in just a second. Bye now.